Okay, on to problem 5 of the hydraulics homework. We've got another pipe culvert under a residential high density area in Wilmington, North Carolina. Has a drainage area of 27 acres, and we're going to use this hydrologic contour map to figure out what that is for Wilmington and determine the design discharge for both 10 and 25-year storms. So the first thing we're going to do is take a look at this map and see if we can figure out what the hydrologic contour is for Wilmington, North Carolina. So we'll come down here to the coast and find Wilmington. And we can see these threes all over the place when that is our lowest. We do have a 4 line coming around here, and then we also have this circle here, which we're going to assume is a 4. So we're somewhere between that 3 and 4. So I went ahead and called that Wilmington hydrologic contour a 3.4. You might have called it a 3 or 3.5, 3.3, something like that. So that will make our numbers a little bit different. But remember, once we've got that contour, then we turn the page to the next chart, to that highway drainage chart. Use the Urbannoma Graph, and we're going to connect those lines. So from the 3.4, and then our drainage area is 27 acres. So it was given to us, 27 acres. So we're going to try to connect that 3.4 and 27 and see what kind of Q10 we get in the middle there. So here's my 3, and I'll go about halfway there, and then here's my 20, so 25, 27, so we're kind of getting into the middle of that, and so we'll go ahead and draw a line and connect those two and see where we wind up in the middle. And in the middle, we're just right, if this is our 20 line, this is 40, so 30 is halfway, and then halfway between 20 and 30 is going to be 25. So I called that Q10 25, so as long as you're somewhere in that ballpark. So that's just reading it right off the chart. I get the 25 CFS off the chart, but I know I'm going to have to do some adjustments because I am told that it's a high density, residential high density area. So I'm going to look at my residential high density, and I see from my chart here for residential high density that is the 0.85 multiplier. So I'm going to do residential high density. I'll take that, find that new Q10. So it's going to be the 25 cubic feet per second, which is what I got right off that chart, but then multiply it by that 0.85 factor, which gives me 21.3 cubic feet per second to 1 decimal place. And then I also want to find a 25-year storm, so I'm going to also do Q25. And the way I can do that is I already figured out for the high density, so I'll take that 21.3 and then convert that by multiplying it by that 25 factor at the bottom of the page. So let's take a look at what that is. For Q25, we convert the Q10. Make sure you can see it. We convert the Q10 to the Q25 by multiplying it by 1.35. So we'll take that 21.3, multiply it by 1.35, and to 1 decimal place, 28.8 cubic feet per second for the 25-year storm.